Hi there, myself Pranshu Dumra, a student at Chitkara University, currently enrolled in Bachelor of Engineering, Software Engineering Global Program in collaboration with Deakin University, Australia, which according to me is a very unique curriculum that we follow here at Chitkara. Most of the content that we learn in software engineering is of Deakin University, and all the expertise, the faculty is of Chitkara. I'm given with a project for which I have to propose an idea for the unit computer systems, for which I'm going to work on soon. After doing some decent research, I have decided to make an automatic sun tracking solar system, which will be beneficial in a lot of ways, like maximizing the sun energy absorption and converting it into the electric energy. More electricity will be produced at the similar cost of the fixed solar systems. There is a lot more about this project, that how the things work in this project, what are the hardware components requirements, what are the software applications. I have covered everything in a presentation, so let's directly switch to the presentation. So here comes the introductory part. The task is task 1.7. It is a high distinction task. Then the title of this task is dual axis solar tracker, as the angular movements of the solar panel depends upon the two axes. The unit name is SIT 111. Now let's jump to the next slide. Here come the objectives of using automatic solar tracking solar system. First comes the efficient use of solar panels. As we know, nowadays everyone is opting for solar energy, but the efficiency and sustainable design plays an important role, as the automatic adjustment of the solar panel by tracking sun will increase the sun energy retention and boosting the electric energy output. The use of this in smaller businesses will eventually help in significant cost cutting. Secondly, people use various sources of fossil fuels like petroleum or gasoline, which proves to be very harmful for the environment, increasing the global warming day by day. Not only the fossil fuels used in the houses, but also used in vehicles produces a lot of greenhouse gases. But the vehicles nowadays have switched to the electric vehicles. So switching to the solar energy will be beneficial in environmental ways, not only in houses but also in the service sectors like schools, hospitals, or government centers. Next comes the cost efficiency, in which people use some other sources of energy instead of solar, like fossil fuels such as petroleum or gasoline, which need smaller investments frequently. When they are used to their fullest, or borrowing energy from the government also takes away money in smaller sections, eventually spending uncountable amount of money to get energy on rent. But the things in solar energy do not work like that. It is just an initial investment to fix a solar power plant, and then there is just maintenance that we have to take up after 3 or 4 months. Instead of fixed solar panels, using dual axis sun tracking solar panels increase the production of electricity by 40 to 45%. Eventually, more electricity is produced at lesser cost. Coming on next slide, there are some components hardware requirements that are mentioned. First is Arduino Uno board, as Arduino Uno is the main component of any project, as each and every component will be in setup by connecting them to Arduino Uno board. Next comes the LDR sensors. LDR is a light dependent resistor which is responsible for tracking the light of the sun. Then there is servo motor used for the rotation of the panel. Then comes lithium ion based battery charger module, which helps to charge single cell battery, which shows two indications: the battery is in progress or battery charging is complete. Then there is USB DC setup boost module, which will be used to power up 0.9 volt to 5 volt devices. Then there is 18650 rechargeable battery cell used to provide energy. Coming on to next slide, There are software applications that are explained. So first, here we'll code the Arduino Uno board using Arduino IDE software, in which servo motor will be connected using two pins of the LDR sensors representing servo motor's start and stop position. There will be some conditions that we have to keep in mind. First is that both the sensors must receive equal amount of light. Position must not exceed the angle that can disbalance the panels, and the algorithm must be updated at the frequent times to experience the best of the solar panels. Proceeding further, we can see a code overview in which there are some libraries that are declared which will be used in the code. Like the first is servo library, then there are some example of variables to get an overview that the points will be used. Also there is a circuit diagram to take a reference of the idea. So that's all from my side.